Hello, everyone. I'm Jennifer Sandman, Associate Director and Assistant Professor at the University of Nebraska Medical Center Human Genetics Laboratory, and it's my pleasure to welcome you to AGT's webinar series. For those of you who are not AGT members, please consider joining the organization so that AGT can continue to be the voice of the technologist in the laboratory community and be able to offer programs like this in the future. Please check AGT's website, www.agt-info.org, to see the many benefits of membership. I will just share that AGT has been a really great way for me to network with other laboratories, particularly to discuss protocols and troubleshooting strategies. And in addition, I'm currently serving as the annual meeting director for the 2017 meeting, which has given me a great opportunity to work closely both with the board and with the AGT membership and colleagues in the field who aren't members as well. It's been a really rewarding experience to be part of that planning process. Today's webinar is very timely as we're looking to freshen up the format for the 2017 meeting, which will be held next June. And one of the exciting changes for that meeting includes doubling the number of abstracts that will be accepted for presentation during the meeting. Hopefully you'll gain a lot of really helpful information today that you can use as you think about submitting future abstracts, either to the AGT organization or to other organizations as well. There are just a few housekeeping notes before we get on to today's presentation. Please feel free to ask questions during the session. In the upper right side of your computer screen, you will see a control panel. In the lower portion of that panel, you can type in a question or comment and submit it to the webinar organizers. You can do this at any time during the presentation. We will reserve about 10 minutes at the end of the presentation for questions and answers. If you're participating as a group, please designate one person in the group to complete the online evaluation. In order for everyone to receive their certificates of attendance, that person will need to enter the names and email addresses of each person who is participating at your site today into the evaluation. As a backup measure, you can use a sign-in form as well and fax that to AGT. Certificates will be emailed to participants approximately 30 days following the webinar. Today, Veronica Ortega will discuss how to write effective scientific abstracts for presentation. Veronica has been in the cytogenetics field for 16 years and in supervisory roles for 7. She has been a member of AGT since 2011 and submitted her first abstract that year. Veronica was selected for platform presentation and won the Best Platform Presentation Award. She continued to submit abstracts, and for the following 2 years, Veronica was selected for the platform presentations and won Best Platform Presentation Award both times. She has also submitted abstracts to the Association for Molecular Pathology, where she competes for the Technologist Award, winning the award in 2014. Veronica feels the best way to learn about something is to research it, write about it, and explain it to someone else. So with no further ado, Veronica, I'll turn it over to you.
Thank you so much, Jennifer. Today, I'm going to talk about some principles for writing effective scientific abstracts and applying these same principles to presentations. An abstract is a short and concise description of a larger work. It's an original document and may act as a standalone entity instead of a full paper. Although not always bolded, scientific abstracts consist of an introduction or background information, methods and materials, results, and an explanation of why those results are important. So why should we care about abstracts? Because abstracts allow readers who may be interested in a longer work to quickly decide whether it's worth their time to read and have confidence that it's relevant to their research. Also, abstracts are used by many organizations as the basis for selecting research posters, platforms, and oral presentations or workshop presentations. And this is the focus of today's webinar. So let's get started. Before we begin writing the abstract, there are some things you may want to consider. Get to know your topic. You should understand the science behind it and why it's important. It will help to look up research papers about your topic and see what others have done. PubMed is a good resource. Look for papers with larger cohorts, not just one case study. And correlate your results to the literature. Has your research been done before? And if so, how is yours unique? Do you have something novel that's never been reported? And talk to others in the field, your peers, director, pathologists. Is your research or case study relevant? And remember, you're going to tell a story, so make it interesting enough to captivate your audience. So what's unique about your story? Has it been told before? Or is this a brand new story? And that's what you really want. And just like a story, your abstract will have a beginning or background information, middle or your methods and results, and the ending, which is your discussion or the impact of your findings. So let's go over each section. I found this blog online by Steve Easterbrook, who's a professor at the University of Toronto, and I wanted to share his concept of the 6-sentence abstract with you, which also includes my non-professional insights to writing an abstract. He cleverly wrote this abstract about writing abstracts. Each of the 6 sentences describes the function of that sentence, and I've broken it down into 4 sections which pertain to the scientific abstracts that we write in our field of work. 3 sentences are dedicated to the introduction or background information, followed by methods and materials, results, and discussion. Steve says that the key trick is to plan your argument in 6 sentences, and then use these to structure your entire paper or presentation. Now let's look at each section. Section 1. He says the first sentence of an abstract should clearly introduce the topic of the paper so the readers can relate it to other work they're familiar with. However, an analysis of abstracts across a range of fields shows that few follow this advice, nor do they take the opportunity to summarize previous work in their second sentence. A central issue is the lack of structure in standard advice on abstract writing. So most authors don't realize the third sentence should point out the deficiencies of this existing research. Section 2. To solve this problem, we describe a technique that structures the entire abstract around a set of 6 sentences, each of which has a specific role, so that by the end of your first 4 sentences, you have introduced the idea fully. Third section. This structure then allows you to use the 5th sentence to elaborate a little on the research, explain how it works, and talk about the various ways that you've applied it. For example, to teach generations of new graduate students how to write clearly. And last section, this technique is helpful because it clarifies your thinking and leads to a final sentence that summarizes why your research matters. So as he explains the rule for each sentence, he's actually written an abstract. Now we'll take a closer look at each step in the next few slides. Step 1 is the first sentence. Here you'll introduce your topic in a way that your audience will understand. So you should know your audience. If you're writing about a novel mechanism to explain tumorigenesis for a submission to a conference specifically about tumorigenesis, then your audience may already be familiar with the content, so you can get to the point. If you're submitting the same abstract for presentation at a conference like AGT, the audience are your peers, so they may know some background information, but you may want to expound a little more on the basis of your research and then specifically describe your topic. Step 2 is your second sentence. Your first sentence, introduce the topic, now build on that and focus on the question regarding your topic. If you can't summarize your research in one key question, then you don't even understand what you want to write about. Keep working on this step until you have a single, concise, and understandable question or problem statement. Step 3 is your third sentence and the last sentence in your introduction section. Boil down in one sentence how your research is different than others of the same topic. Basically, you're introducing your research, work, or case study. The third sentence in Steve's abstract says you should point out the deficiencies of the existing research. And essentially, we're doing this by presenting to the science world the bigger and better research bigger and better idea or research. So don't describe all the ways it's been done before, but do explain the one approach that nobody else has tried yet, which is your interesting case study or your research. And step 4 is the fourth sentence in the methods and materials section. In one sentence, describe your methods and materials used. If it's a case study, what tests were utilized and how did you discover the uniqueness of this case? Step 5 is the fifth sentence within the results section. This might be the longest sentence because you're summarizing your data, but summarize only and leave out the details. Here, you're merely describing the outcome of step 4. Step 6 is the last sentence covering the discussion section. What does it mean? Why should people care? Here, you will explain the clinical significance of the findings of your research or case study. And in 6 sentences, you have an abstract. The 6-sentence abstract is just a general technique to follow. Obviously, you may add more sentences for each section, further breaking down or explaining your information. But remember to keep it simple since it's only a summary of your work. In the next few slides, I'll break down an abstract that I previously wrote and submitted and was selected for a platform. This is an example so you can get a better idea of writing an abstract pertaining to our field. So remember step 1, introduce your topic and know your audience. Genomic instability is thought to arise through a gradual multi-step process, but recent genome sequencing studies have led to the identification of a novel phenomenon called chromothripsis, which suggests an evolutionary modality for cancer cells to circumvent individual mutational events with one simultaneous shattering of chromosomes, resulting in the random reassembly of segmented genetic material to form complex derivative chromosomes. So this abstract was submitted to AGT, so my audience is familiar with the topics in genetics. Step 2 is your central question. State the problem. While chromothripsis is well documented in solid tumors and leukemias, chromothripsis in lymphoma is rarely reported. The audience should wonder, why is chromothripsis in lymphoma rarely reported? Previous work is also summarized here. Step 3 is where you introduce the uniqueness of your research. We report a case of possible chromothripsis in a patient presenting with a thyroid mass suspicious for lymphoma, where histology and immunostaining revealed that the mass contained a characteristic pattern of diffuse large B-cell lymphoma. The uniqueness is possible chromothripsis in a lymphoma case. It's different and better than other chromothripsis cases because it could be something never reported before. Step 4. Describe your methods and materials used. Chromosome analysis from the biopsy was performed along with FISH for the B-cell lymphoma probe panel and array comparative genomic hybridization studies using Cytochip 60K custom oligo array to further investigate and confirm the findings. The methods here are chromosome analysis, FISH, and microarray. And then step 5, summarize your data, but leave out the details. The results showed a complex karyotype, including a translocation of chromosomes 3 and 7, involving the BCL6 gene region, confirmed by FISH, with the derivative chromosome further rearranging with chromosomes 14, 7, and 22, with involvement of the IGH gene region, confirmed by FISH, and multiple complex copy number variations by microarray, including a previously unidentified chromosome 12 abnormality in which the complexity appears to confirm the phenomenon of chromothripsis. The data is summarized without disclosing too much detail. Step 6, explain the clinical significance of the findings. Our patient's genomic abnormalities show characteristics suggestive of chromothripsis and provide initial evidence that chromothripsis is not confined to solid tumors, but can also be seen in B-cell lymphomas with well-characterized 1- or 2-step lymphomagenesis. The clinical significance of this finding is that lymphomagenesis can arise via chromothripsis in B-cell lymphomas, which is a new and novel concept. And here is the completed abstract written in 6 sentences, including all 4 sections. So next, we'll switch gears and transform this abstract into a PowerPoint presentation. Before we begin, here are some general guidelines to consider. For the title slide, create a catchy title to attract the audience. The subject of the presentation should be new and cutting edge. Include an engaging or entertaining illustration, for example, a cartoon, and introduce yourself and your company on the title slide. For slide format and design, stay away from a busy or flashy design so it doesn't take away from the content. Use bright colors to keep your audience alert, but stay away from dull or neutral colors. Keep bullets, spacing, font, and font size the same. Stay uniform throughout the presentation. For the slide content, use few words as possible. Maintain clean and visually easy to follow slide material. Use pictures and illustrations as much as possible. Animations are a good tool to use to describe steps or mechanisms. Verbally explaining a scientific process takes comprehension time, which is limited during a presentation. Now let's go from abstract to presentation. Follow the same format as the abstract. Introduction and background information, methods and materials, results, and discussion. So for the abstract, the introduction section consists of 3 sentences, and having 2 to 3 slides per abstract sentence is average. So for the introduction, there will be 6 or more slides. And one thing to consider is the time you're given for the presentation. This will determine slides to make. Again, know your audience. This will give an indication of how far back you want to go with the background information. Stay on topic. Only give background information pertaining to the topic, just enough for the audience to understand the idea behind your new approach or research. Again, illustrations and animations are a great way to describe mechanisms. And if animations are used, verbally narrate what's happening in each step so that the audience can follow. Methods and materials will probably be the shortest section, about 2 slides. If there are several parts to your study, of course it will be longer. Also, if you have to explain technique, then you may have more slides. Again, you should use pictures here. To list tests performed or a case report, bullets are good to use. Results will most likely be the longest section, about 6 or more slides. This is the outcome of your big idea, so use as many pictures as possible to explain and simplify the data. Summarize results you want to emphasize or point out, and show the audience how your data or results are interesting, whether the experiment worked or not. Use few words as possible in these slides. And for the discussion, explain the clinical significance and implications of your findings. Does it impact patient care, or will the new technique or approach improve, for example, turnaround time or productivity in the lab? Use more animations and illustrations here if possible. And usually I have a summary slide of the key points that I want my audience to take away from the talk. Here you can see how the background information is broken down to thoroughly define and describe the phenomenon of chromathripsis. Chromathripsis results in the random reassembly of genomic segments forming complex derivative chromosomes and deleted regions. Chromathripsis differs significantly from the mutational progressive method. Notice how I used animation to advance each statement instead of showing the information all at once. I introduce the information in steps so that my audience can focus on what I'm saying. Providing the information all at once distracts the audience from listening, since they may start reading ahead or fall behind and become easily confused. So in the first example, I listed information about how chromathripsis exists, but this example demonstrates background information using an animation. I show a chromosome which has undergone a stress stimulus, disrupting the original chromosome sequence by synchronized shattering, resulting in a derivative chromosome. I play the animation while verbally explaining the mechanism. And at the bottom, I added information further describing the event. So this slide is to demonstrate the complexity of the animation which occurs behind the scenes. You may be thinking that it looks cumbersome to create. Well, you're right. But remember, the clock is ticking and you have important information to deliver, and lots of it. So a visual illustration helps the audience understand the content faster and allows them to follow what you're saying. I usually include a case report in the methods section because this is in the laboratory. This is where we learn about the patient and what tests are ordered. So our patient is a 59-year-old Caucasian female with a history of hypothyroidism. She noticed swelling in the neck 1 to 2 months before presenting to the clinic with a rapidly enlarging goiter causing significant dyspnea. CT scan showed extensive infiltration and enlargement of the thyroid gland with significant effect on the trachea. Thyroid biopsy showed sheets of large dysplastic B cells, diagnostic of diffuse large B-cell lymphoma. Since my abstract is a case report, I merely listed the patient information one statement at a time. This slide shows the sample type that we studied. And then I listed the tests performed with some information about each test. They're listed one by one in the order they were performed in the lab. And in my results section, the same sequence will be used. So the results of the chromosome analysis are shown here. I use arrows to focus the audience's attention to the chromosome of interest, like on the derivative 3, the derivative 7s, and the derivatives 14 and 22. And notice how I underlined below so the audience can correlate the two. By using animations effectively, I simplified a busy slide for the audience. So on this slide, I'm using an animation to explain the mechanism that led to the abnormalities that you saw on the previous slide. Again, the translocations of interest are underlined below. In this animation, I'm showing the FISH results, which confirm the ring 12. I show the chromosome next to the metaphase to remind the audience what it looked like on the karyotype, and I use an arrow to focus their attention to the metaphase FISH signal. In this example, I show the microarray results of chromosome 12. On the ideogram below, I show the duplication sections in pink, while simultaneously underlining the breakpoints on the top table so that the audience can correlate the two. The same is done with the triplications highlighted in blue. So this slide demonstrates the mechanism by which the ring chromosome 12 was formed. We hypothesized that the chromosome 12, through an unknown catastrophic event, shattered into pieces with duplications and triplications of the pericentromeric segments, and loss of the telomeric segments led to a ring formation. This example shows that animations can also be used in your discussion section. I usually have a summary slide at the end of my presentations. This was the case of diffuse large B-cell lymphoma with complex abnormalities suggesting chromothripsis. It's the first case of DLBCL without IGHBCL2 gene rearrangement, but presenting with multiple other abnormalities indicating genomic instability. FISH studies show complex rearrangements involving BCL6 and IGH genes, which on array analysis appear to be balanced. Microarray studies suggest chromosome 12 has duplication and triplication of both 12p and 12q, with loss of telomeres resulting in a ring formation. So our case suggests that B-cell lymphoma can arise from genomic instability caused by one single catastrophic event instead of incremental steps seen in most cases. I included just the key points of my presentation and read them one by one. So here's some information that you might find useful. Make your story flow. The last sentence, words, or picture can be the topic for your next slide and can serve as a clue to what's coming next. So write notes for your presentation. Write down what to say for each slide. This helps me collect my thoughts and what I want to convey to the audience. Practice your presentation. This is very important if you have animations because you need to know the timing of when to speak during the animation. You can practice alone, with friends, with family, a mentor, but practice with people who will give you honest and useful feedback. And time yourself and realize that your nerves will usually speed you up during the actual presentation. Know your slides. I usually add words as reminders and familiarize yourselves with what's coming next. Make eye contact. If you get nervous or distracted by making eye contact, look across the room and to both sides. It will still look like you're engaging the audience. Speak clearly and pace yourself. Speak close to the microphone. And I usually pace myself by using animation entrance effects for the sentences. Like I said, putting them on the screen one by one will help with pacing. And nerves. Nerves are inevitable. I'm always fine all the way up to that very moment. So to stay calm, I like to be alone and collect my thoughts and meditate right before my presentations. So in summary, we learned about the 6-sentence abstract. Step 1, introduce your topic. Step 2, state the problem. Step 3, introduce your idea. Step 4, list your methods. Step 5, explain your results. And step 6 is your discussion. The presentation follows the same format using 4 sections. The introduction, which combines the first 3 steps of the abstract and introduces the background. The methods, which lists the tests performed, techniques, and materials used. The results section, to explain and summarize your data. And the discussion, which is an explanation of the results and the implications and clinical significance and impact of your findings. I hope this information that I presented today is useful for your future abstracts and presentations. And before we move on to questions, I'd like to thank 2 groups of people. The first group is my work team. And Dr. Villa Galetti, my director and mentor, has been instrumental in guiding and supporting me. And the rest of the team has also been so supportive. I make them sit and listen to me practice. And they're listening to me right now. So guys, thank you for your support and confidence in me. It means so much. And the second group is my sweet family. Almost every year around June and November, they have to listen to me practice. And sometimes they leave the room or fall asleep, and I left with just the dogs and the cat. And lastly, I just want to reiterate what Einstein's words are here. You don't have to be a genius. And honestly, if I can do it, anybody else can do it. And I say this because the first year I submitted an abstract to AGT, I got a platform. And it was my first year ever attending a meeting. So that's wonderful, right? Yeah, but it was also the year that I got promoted to become a manager in my lab with a new director. So I was super excited, but also super scared because I had never in my life opened PowerPoint. And I couldn't admit that. I was so embarrassed. How did I get this far without ever using PowerPoint? And at that time, I thought everyone had experience with PowerPoint except me. So I told no one. I went home and researched my topic, which was donor cell leukemia at the time. And I read article after article. I studied and I learned about it. Then I opened up PowerPoint and played around with the animations. And that year, I won the Best Platform Award. So, like I can do it, anybody can do it. And I hope that I've helped in just even a small way today and encourage you to submit abstracts for platform to AGT. Thank you so much for listening. Jennifer?
Thank you so much, Veronica. That was fabulous.
Thank you.
We have just a little bit of time for a few questions. And the first question that I kind of wanted to start with is, what is your best source of abstract ideas? Is it typically a unique case? Is it a designated project that you brainstorm with the team kind of early on in the year? Does it come out of your validation? How do you come up with the ideas for your abstracts?
Actually, it's all of the above. So in our lab, we're constantly doing like parallel validations, or we're bringing on a new test, or we have maybe a new instrument or something. So, and then of course you always have your interesting cases. Sometimes you don't even have any cases that might be that interesting or worth presenting, but we try to pick one of those things, and then we actually discuss it kind of together in my lab, and especially with the director. And then we decide what would be the best way to go about it and which topic is the best to present at AGT. And you're not only just presenting an abstract to get a platform, you're trying to lend a helping hand to your fellow laboratory. Maybe it's a technique that you came up with, so you want to share it because it's important. It might be important to share this for better patient care. So things like that. I mean, like I said, it's all of the above.
Great. Yeah, thank you. I think that the experience in our laboratory is very similar, and I think one of the things that people don't often think about is a process that might be really innate in one laboratory is maybe something another laboratory hasn't ever considered, particularly when it comes to troubleshooting. So I think, yeah, really considering those unique things that you do in your laboratory and sharing them for better patient care, I think that that's absolutely critical.
Exactly.
Another question that we have, what editing process do you send your abstract through? Do you first run it by a colleague, a director? Do you run it by someone outside of the field entirely? How do you kind of get that ready for submission?
A very stringent process here in our lab, and it's all of the above. And I say that because I guess we're all perfectionists here, so I kind of like, if it's my abstract, I write it, and then I might share my thoughts and ideas with a colleague here, and then once I'm ready to share it with somebody like my director who might tear it up, I do that. But if that happens to you, don't take it personally. They do that because they want you to put forth the best work. You are representing your laboratory. So yes, colleagues, and of course you're going to also research the articles, like I said. So you're also running it through other research studies, and how does it compare, and things like that, where you're going to get the science and all the background. And then like I said, in our lab, our director is a great mentor, so he double checks our science and background and how it sounds. I take ideas from the AGT annual book that they give you, and there's abstracts in there, so I take bits and pieces from everywhere. And previous abstracts, how did I write it? How did I, what kind of words do I use? And then also, like, if I want to think of a different word, I just click on the word, right click, and you get synonyms, So there's all different ways, all of the above again.
Great. Yeah, I think often when we're working on abstracts in our lab, we will use old abstracts kind of as a starting point. This got accepted, it was, structured in this way, and it usually morphs over time as you focus on the subject matter of that particular abstract, but it does kind of at least give you a jumping off point. So we work very similarly, I think. Another question, what tools have you used to gain confidence in presenting? I can remember the first time I presented at a large national meeting, and admittedly it was definitely not my best presenting experience. I'm sure we all kind of have those first presenting stories, where the nerves are high and the confidence level is low. But given that we are going to be expanding and really interested to have more people contributing to the AGT meeting, really getting feedback from labs, what tools have you used to gain confidence in your presenting skills?
Like I said, two things. Practice your presentation, and especially if you're the type to get nervous, which I am. I get very nervous before I present. So I like to practice, because if I don't, I think I might go up there and just forget every single thing. My brain is like empty. So I like to practice and surround yourself with people who support you, and not just your colleagues, also your family. They're going to give you the best criticism because they don't care, and they're just going to tell you exactly how it is. And so I think those are the practices that I use.
Great. And can you just comment a little bit on your experience presenting at AGT, kind of in terms of audience, how receptive people are, whether you feel like it's a fairly warm and welcoming group, if it can be a little bit intimidating?
Sure. It is intimidating, especially if you've never presented before. Like the very first time I presented, I was so scared. But at the same time, it's a lot of fun. I think it's a lot of fun because when you're researching and learning about the topic, that's the best way you're going to learn about something, and that's the best way that you're going to be able to share that with somebody else. And yeah, it was intimidating, but you know what? Afterwards, I've always had a good reception, and even though people may not ask questions right after your presentation, there are sometimes people who come and talk to me afterwards, or they email me, or they call me and ask me, can you help us with this, or we found the same thing in our lab, what do you think, things like that. And it's fun to talk to them about it. So that's my experience. I think that AGT is a great place to meet people that are in the same, situation as you. And so you don't feel so alone. Like at the beginning, I thought I was so alone because I had never made a PowerPoint presentation. But now that I know, not everybody does that. And I didn't know that at the time. I thought I was just the only one. So I was super embarrassed and didn't tell anybody. But even after that first time, it was so good to feel so welcomed at AGT.
Great, yeah, and I think that's been my experience as well. I've been surprised at the number of people who might not ask questions during the session, but then we'll follow up to kind of one-on-one privately. And it builds really some great connections, and usually takes the research in an even more exciting and comprehensive direction. If you give a case study, I've had the experience of giving a case study in the past, and there's always one or two people out there who've had that exact same or very similar experience or case, and suddenly now you have three of them, and your power is a lot greater. So,
yes.
Well, thank you so much for your time today, Veronica, and for your expertise. And thank you to all of those who tuned in to participate in this webinar. We don't have any additional questions coming in at this time, so I think we'll kind of conclude at this time. Shortly, webinar participants should be receiving an email from AGT that includes a link to an evaluation. Please take a few minutes to access it and provide your feedback on today's session. The webinar today was recorded, and it will be posted on the AGT website in the near future. We hope you will join us for upcoming webinars over the next few months. We will send out a notification to members once registration is available for our next webinar. And we also, as we've mentioned, we hope to see you all at AGT's 42nd annual meeting. Next year, it will be held in St. Louis, Missouri, June 15th through the 17th, 2017. And be looking for registration to open early in 2017, and also be looking for that request for abstract submission. It really is a meeting for the membership, and we want it to be a meeting kind of the membership as well. And we really welcome everyone's contribution and the work that they're doing in their laboratories that we can kind of share among colleagues and really provide the best patient care, as Veronica mentioned. So again, Veronica, thank you so much for your expertise today. This has been fabulous.
Thank you so much for having me.
Absolutely. And with that, we will conclude today's session.